See, so now I'm telling you about the solubility curves. So the solubility is greatly affected by the temperature. So if I plot the solubility against the temperature, we get different kind of curves. In certain cases, what happens, it increases with increasing the solubility, just increase with increasing the temperature. Sometimes the increase is only slight, and sometimes it decreases with increase the temperature. So that means when the solute is dissolved in a solvent, so what happens? Sometimes on increasing the temperature, the solubility increase, sometimes the solubility decrease, sometimes the solubility, you can say there is an increase, but the increase is only slight. So on the conclusion, we conclude that the solubilities, or you can say what is actually the use of knowing the solubilities. After knowing the solubilities, we are able to, you can say, we can just conclude the three things. First, we can know that how much of the solute can dissolve in a solvent. Secondly, we can just compare the solubilities of different solution. And third, we can know that whenever you can say we cool the hot saturated solution, so what amount of the crystals that separate out. So coming to this third point, you should know that when what is in saturated solution, you know that it can dissolve solute only up to certain level at given temperature. But when we heat it, what happens? It's you can say it dissolves the solute more than its saturation level, right? So that means when the hot saturated solution is that which contain the solute dissolved in it more than its saturation level, right? But what happens when I cool that hot saturated solution? So when I cool that hot saturated solution, what happens? The solute which is dissolved starts separating out as a crystal, and just at the end, we just when we cool it more and more, we get to see the beautiful you can say the colored crystals. Sometimes they are colored, sometimes they are non-colored, but still we get to see crystals after that, crystals separating out. That means the solute just gets separating out when we are cooling it, because when we cool, the solubility just decrease, the solute starts separating out, right? So now coming to the point, you should know what actually the crystals are. Crystals are just a homogeneous solid, right? And obviously the structure they have is a symmetrical. So they have symmetrical structure, right? And they just have the different edges. You can say they're definite edges, different edges which are meeting at different angles. So this is how we define the crystals. That is the homogeneous solid, symmetrical in structure, different edges meeting at different angles, right? So we have the crystals. But you know, sometimes what we get to see along with the crystals, some crystals have the water you can say combined with them, and few crystals are like they don't have the water combined with them. So that water which is chemically combined with the crystals is called as the water of crystallization. Now what is that? I'm just stating an example for you. See, the copper sulfate, if I say copper sulfate pentahydrate crystals, what does it actually means? It actually means, obviously it is a copper sulfate. Then what do I mean by writing this 5H2O? So whenever you get to see this kind of water just written with the molecular formula with the point in mid, it means a water of crystallization, the chemically combined water. That means this chemical has chemically combined with the water, right? So whenever the crystals on cooling, when they separate out and they just combine with the chemically combined with the water, they are said to be hydrated crystals. That means they possess the chemically combined water, that is the water of crystallization. And those crystals which do not possess this kind of, you can say, the crystals and all, they are said to be anhydrous crystals. So this is you should know, like we use different terms. Sometimes you get hydrated copper sulfate, sometimes you get anhydrous copper sulfate. So you should know what is the difference actually the hydrous and the anhydrous has. Right. Similarly, I'm making you familiar with few more terms. One is efflorescence. Now, what do I mean by efflorescence? Efflorescence is actually, I'll explain you with an example. See, washing soda is actually Na2CO3 10H2O. You must be familiar with the washing soda. Washing soda has a great importance. It is, you can say, it is used in the glass industry. It is also used in the detergents as well, because it has a cleansing action also. So the formula which denote the, you can say, the washing soda is Na2CO3 10H2O. You get to see this 10H2O, this means it has a water of crystallization. Now, what do I mean by saying the property efflorescence? This means that when I expose this washing soda in air, what happens? These crystals, this water of crystallization get evaporated and it turns out to be anhydrous sodium carbonate. We just, you can say, we assume that out of 10 H2O, all the 10 H2O might, out of these 10 H2O, the 9 must have been evaporated. That means it must be left with at least minimum 1 water molecule. So we write 9H2O, because when we expose something to air, so it obviously the water get evaporated, but it is assumed that not all the water get evaporated. The whole water can get evaporated when we heat a substance. So there should be a difference when we heat a substance and when we just keep in air, because when we heat it, all the water which is present has the ability to get evaporated. But when we are keeping in air, we are assuming it that not all the water molecules, the few molecules just remain with the compound and the few gets evaporated. So this is efflorescence. So what is efflorescence? It is the loss of water of crystallization when any substance is just exposed to an air. For example, in this case, I have exposed washing soda in air. So the loss of 9 molecules of water of crystallization when washing soda is exposed in air is called as efflorescence. So you should know with the terms, because we get confused with efflorescent, deliquescent, hygroscopic. These all terms are related to the water of crystallization, but there lie a difference between them. So whenever I told you in a previous lecture as well, when you are studying anything, just get into it. Don't get confused with the terms which are synonym to each other, right? So efflorescence just means the losing of water of crystallization. How? Not by heating, by keeping in air, right? So this is called as efflorescence. Now the other term which I want to tell you is we have few molecules as deliquescent molecules. What they have? They have a tendency, like when we keep these, you can say, substances in the atmosphere, what they do? They absorb the moisture from the air, and when they absorb the moisture, they just convert their state. Right, so they are called as deliquescent. So deliquescent molecules are those which has the ability to absorb moisture, but they absorb the moisture up to so extent that they just, you can say, they change their state as well. They start becoming, you can say, they appear to be semi-solid type, means they have a liquid state also, they become wet, right, in that way. So we have the term deliquescent. So I think efflorescence is clear. It is just the loss of molecules, and deliquescent means absorbing the moisture and also the converting its state also. We have one more, you can say, the state, that is the hygroscopic one. What is the difference lies between these two terms? In both the cases, when the substance is, you can say, exposed to air, it is absorbing the moisture. Whether it is deliquescent or it is hygroscopic, in both the cases, the substance is absorbing the moisture. But the difference lies in here, that in deliquescent, the substance is absorbing moisture up to an extent that it is just converting its state. But in hygroscopic, it is not converting a state. The moisture just form a film around the molecule. So this is how we differentiate between the deliquescent and hygroscopic. Don't forget it. Don't get confused. Deliquescent, in which the substance absorb moisture and change the state, and in hygroscopic, the moisture just form the film around it, but do not change its state. Right. The other term which is related to the water is striking in my mind is the dehydrating agent. Oh, sorry, we can use dehydrating, which we can also use the drying agent. I think drying agent will be the appropriate term to be used. Right. So drying agent is that which can absorb moisture from any substance, or it is from air, whether it is from air or whether it is from any substance. So it has the ability to absorb the moisture and make that substance dry. Like we use, you can say, the quicklime. It has a tendency to absorb the moisture from the air or any other substance we use. So just making you familiar with these terms, that how they, you can say, what is the water of crystallization, how they behave toward the water, when they become hydrated, and when they become anhydrous, what is the difference between the deliquescent and the hygroscopic, and what are the drying agents. So I think it is clear that these deliquescent, hygroscopic, drying, efflorescence, they seem to be similar, but actually they are very different, right? So this is how we use these different terms in different situations.